Have you ever looked at a graph and wondered, how can someone tell so much just by looking at this picture? How do they instantly know where an equation equals zero? How can they tell where two equations are equal? What is the relationship between these geometric shapes and numbers? And why do mathematicians spend time drawing graphs instead of simply solving equations? By the end of this lesson, inshallah, you'll be able to answer all of these questions and read the most important information from a graph in just few seconds. So, welcome back. This is lesson 3 of our Functions and Graphs Made Easy playlist. If you haven't watched the first two lessons, I highly recommend starting there, because we are already learning what functions are, function notation, how to evaluate functions, domain, and range. Now we are ready to visualize functions using graphs. So let's get started. So what exactly is a graph of a function? A graph of a function is the set of all points whose coordinates are x above x. Every point of the graph tells us if the input is the x value, then the output is the y value. For example, the point 2, 3 means f of 2 equals 3. Similarly, the point minus 1, 0 means f of minus 1 equals 0. Notice something very important. The graph is simply a picture that shows every input together with its corresponding output. Before we continue, let's answer an important question. Imagine someone gives you the following table of values. This table certainly tells us something, but it's difficult to immediately recognize the overall pattern. Now, let's plot these same points on a coordinate plane. Suddenly, the relationship becomes much clearer. These points are on the same line. Instead of reading numbers one by one, the graph allows us to understand the entire function at a glance and generalize this to other numbers. Graphs are one of the most powerful tools in mathematics because they summarize a tremendous amount of information in a single picture. Notice that the graph we just drew is made up of only few separate points because we only choose a few input values. However, many functions accept every real number as an input. In that case, there are infinitely many points and together they form a continuous graph instead of isolated points. Now that we know what a graph represents, let us see how we can determine the domain and the range just by looking at it. A simple way to think about it is this. The domain is everything the graph covers horizontally. In other words, it is the projection of the graph onto the x-axis. The range is everything the graphs cover vertically. In other words, it is the projection of the graph onto the y-axis. Notice that sometimes the domain or the range of the function is unbounded, meaning it extends forever. Because of this, we usually draw only the part of the graph that best shows the important behavior of the function. Let's look at an example. Consider the function f of x equals 1 over x. The domain is all real numbers except 0, and the range is all real numbers except 0. This is its graph. Notice that there is no point on the graph whose x-coordinate is 0. Likewise, there is no point whose y-coordinate is 0. This perfectly reflects the fact that 0 is excluded from both the domain and the range. Now, let's focus on one of the most important features of a graph, the x-intercept. Suppose this graph crosses the x-axis here. So, what makes every point on the x-axis special? Their y-coordinate is always 0. Therefore, whenever a function crosses the x-axis, the function value is 0. That means f of x equals 0. For example, if the graph crosses the x-axis at 4, 0, then f of 4 equals 0. That is why solving f of x equals 0 is exactly the same as finding the x-intercept of the graph, which is the point x0. We just need to find x where f of x equals 0. Whenever you solve an equation later in algebra, you will often be finding the x-intercept of its graph. Now, let's look at another important feature of a graph, the y-intercept. Where does a graph meet the y-axis? Think about what every point on the y-axis has in common. Their x-coordinate is always 0. So finding the y-intercept is very simple. All we have to do is evaluate the function at x equals 0. Let's look at an example. Suppose we have the function f of x equals 2x plus 3. Substituting x equals 0, we obtain f of 0 equals 2 times 0 plus 3. Therefore, the graph crosses the y-axis at the point 0, 3. So, whenever you are asked to find the y-intercept of a function, simply calculate f of 0. It's that easy. The y-intercept is just the point 0, f of 0. Now, let us compare two different functions. Suppose we graph a straight line and a parabola on the same coordinate plane, like this. Notice that they meet here and here. These points are called intersection points. But what do these intersections actually tell us about the function? Let's think about one of these intersection points. At this point, both graphs have the same x-coordinate. More importantly, they also have the same y-coordinate. That means both functions produce exactly the same output for the same input. In other words, if one graph represents the function f of x and the other represents g of x, then at every intersection, f of x equals g of x. This is an incredibly important idea. It tells us that solving the equation f of x equals g of x is exactly the same as finding the intersection point of their graphs. Here, geometry and algebra are telling the same story in two different ways. Algebra let us solve the equation using symbols. Geometry let us see the solutions with our eyes. Let's see this idea in action. Suppose we want to solve the equation x squared equals x plus 2. One way is to solve it algebraically, but let's take a graphical approach instead. We will graph the two functions y equals x squared and y equals x plus 2, like this. Now, look carefully. Wherever these two graphs intersect, they have the same x value and the same y value. In other words, both functions produce the same output for the same input. Therefore, the x-coordinate of the intersection points are exactly the solution of the equation x squared equals x plus 2. Those x-coordinates are minus 1 and 2. So, x equals minus 1 and x equals 2 are the solutions. This is one of the biggest reasons graphs are so useful. They allow us to visualize equations instead of working only with symbols. In fact, graphs form a beautiful bridge between algebra and geometry. Algebra describes relationships using equations. Geometry lets us see those same relationships as shapes and curves. Now, it's your turn. Pause the video and answer these questions. Question 1. Which point of this graph is the x-intercept? Question 2. Which point is the y-intercept? Question 3. Suppose this graph represents the function f of x, and this graph represents the function g of x. How many solutions does the equation f of x equals g of x have? Pause the video now and see if you can answer all three questions before checking the solutions. So, for the answers, answer to question 1. The point 2.50 is the x-intercept. Answer to question 2. The point 1.8 is the y-intercept. Answer to question 3. The equation has 4 solutions because the graphs intersect at 4 points and every intersection is a solution. So we have 4 total solutions. Let's quickly review what we have learned today. You now know what the graph of a function represents, how to read the domain and range from a graph, what the x-intercepts are and what they tell us, what the y-intercepts are and how to find them, what the intersection points of two graphs tell us about their functions. These ideas are some of the most important foundations for understanding functions and graphs. In the next lesson, inshallah, we'll answer a very important question. How can we tell whether a graph actually represents a function? Inshallah, we'll learn the difference between relations and functions, and we'll study one of the most famous tests in mathematics, the vertical line test. If you want a summary for this lesson and more practice questions, I've put a link to a PDF in the description below. If you enjoyed this lesson, don't forget to like the video and subscribe so you don't miss the next lesson in the Functions and Graphs Made Easy playlist. Thank you for watching and inshallah I will see you in the next lesson.